G'day cobbers, welcome back to the bush. In this episode of Lockups for Driving, we're simplifying and fixing the electricals of the King's Thumper Max air compressor. Make sure you stick around to the end of the video because you will not believe the performance improvements we got from these simple modifications alone. But first up, let's have a look at the testing setup. Now before we perform the baseline runs for the Thumper Max, let's have a look at the electrical side of the testing setup. So we've got a 5 volt regulated power supply here, that's pushing 5 volt into that pressure transducer. That puts out a variable voltage dependent on how much pressure is in the tyre. And you see the gauge at the other end there, the orange one? Well, it's telling me there's 17.1 psi in that tyre at the moment. That's read via this mushy meter here and displayed on the mobile phone here, and that tells me 0.735 of a volt is 17.1 psi. I've also got a current clamp here, and that can tell me exactly how much current at any time the Thumper Max is stealing. Alright, now we know that, and we know we can data log in this mushy meter as we've seen it once or twice before. Let's have a look at the pneumatic side. So we've got the standard pigtail here running into this custom hose. The clear piece of plastic up the top there, that's actually an AirTech air chuck. It allows me to get the Schrader valve out of the road. So I've got consistent and repeatable testing right from now, right through the end, and that's how I'll be doing it from here on in. Okay, now you've seen both the pneumatic and the electrical side of the testing, let's get on with the baseline runs. So we've zeroed out the current clamp. We're going to start the logging here. We're on 18 psi on that tyre. Let's head up to 38 psi. Okay, so we're back up to 38 psi. Now I'm going to conduct this test twice more and let's have a look at the results. On the left hand side we've got the pressure in psi and the current in amps. Along the bottom we've got the time in seconds. So as you can see we had a consistent around about just over 90 amps from start to finish, and we went from 18 psi to 38 psi in 113 seconds, or just shy of 2 minutes. Okay, on with the testing. I've noticed with the Thumper Maxes, after a while the standard lead gets as hot as a $2 pistol. So I'd like to check the voltage drop over it because I think it's a little bit thin. Okay, now unusually for an electronic appliance it actually switches to negative as opposed to the positive. So I'm going to put one of my test leads on this side, and that's the output from the PCB, the negative from the output of the PCB heading directly to the motor. So what I'll do is I'll clip on there, if I can get a decent grip on that one, and I'll start the compressor up and we'll have a look at the output from the bushy meter. And there we go, we're getting about 0.28 of a volt. Okay, so let's work out the percentages. Mind you, the recommended max is 3%. Let's see how this one works out. On the left hand side here, we've got the voltage drop in volts, and you see the maximum recommended is 3%, or in this case, 0.36 volts. We measured on the Thumper Max, well that came in at 0.28 volts, or 2.3%, so it's actually compliant, but just. Hopefully we can do a little bit better than this. Now before we get on with revamping the electricals, the question was asked in the comment section, what does the PCB actually do? And it was suggested that it might be a soft start. I thought, well, yep, that's a decent consideration. It may well be a soft start. We may well be getting rid of that function by going with a direct solenoid. So I thought I'd check it. So unfortunately the mushy meter that I usually use for data logging only takes 1 sample a second. But the oscilloscope, that can take 4,000 samples a second. So what I've done again is got the current clamp and put that onto the positive lead of the Thumper Max, and I'll run it for just a second, and I'll set up the oscilloscope to trigger as soon as there's any current going through this current clamp here, and we'll capture the waveform and have a look. Okay, turn it on for just a half a second. There we go. Now let's check out the waveform. Here are the results of the startup with the PCB. On the left hand side here we've got the current in amps, and along the bottom we've got the time in milliseconds. So 1 millisecond is 0.001 of a second. So a very small increment of time. And as you can see here, nice and linear, and then peaks out at just over 90 amps there in about 2.25 milliseconds. Now we know what the startup with the PCB looks like. We'll be able to do comparison with the solenoid later on. Okay, and now we're going to make a start by stripping off all the old electricals. So firstly these covers. And you'll be able to see here is a pressure switch, and we'll actually disconnect that from the main board. Now we can disconnect the switch from the PCB. Okay. And I think we've pretty much reached the point of no return. It's time to bring out the side cutters and permanently disconnect this PCB. There's one. There's two. And the hard disconnection. That's it. No more PCB. Let's look at what we're going to replace it with. Is a simple 12 volt 4 pole relay. Constant duty. This isn't a starter relay, this is a constant duty 200 amp relay. So positive and negative across these two, and it joins in between these two here. So it's a very simplistic way of operating this. No soft start, it's either on or off. And we'll show you that once it's all hooked up on the oscilloscope and do a comparison with the PCB. Alright, so I've got to start working out how I'm going to mount it. Thankfully it fits under there, but I think it's got to be right in the centre. I might have to pull the heads off just to mount this there. So I'll get on with that. Okay, that's the last 4mm Allen key. So let's lift this head assembly off and have a bit of a look-see. Okay, first thing I notice is the heads and the inlet ports here. These are the exhaust ports. The inlet ports here are horrendously shaped. They're full of casting marks, so there's improvements to be done in the porting. Anyway, and there's our head assembly there. Okay, now I've got a mark on the casing exactly where I'm going to mount this relay. Now after a bit of messing around with a ruler and a felt tip marker, I've decided on the positions there. Right smack bang in the centre. So it'll be sitting about there. All I need to do now is drill it and screw it down. And here's our 2 screw holes. Now we're ready to put our solenoid into its final resting place. Now just a quick note, I did have to shorten up the screws a little bit here because there's not a lot of distance between the cover and the body of the motor below. So you might have to do that if you don't have short screws yourself. Okay, let's tighten this one down. And the next thing we have to do, of course, is to start wiring it up. So this is a negative lead to the motor, and I've decided to switch it just like standard through to the negative lead right through this solenoid here. So we need to put a cable lug onto the negative lead and secure it onto this side of the solenoid. Let's get on with that now. It turns out this wire is 7 gauge. 7 gauge is about 10.5mm cross-sectional area. The closest lug I have is 16mm, so I'm obviously not going to be able to crimp down hard enough in order to make a decent connection there. So what am I going to do? Well, I found myself an extra piece of wire. It's actually 12 gauge, so it gives about another 3.5mm or so. So what I'm hoping is if I jam this wire in there and jam the other wire in there, that I'll be able to crimp down on both of them simultaneously and get a decent connection. We'll find out when we give it a tug at the end. So wish me luck. There we go, we got both wires jammed in there, and I'll start activating the hydraulic crimper. Now, didn't take a heck of a lot of wrangling on it, and I think it's actually going to pull out, but we'll give it a crack and see how we go. Yep, that's not crimped down well at all. So what am I going to do? I'm not going to get myself a 1967 Cadillac Eldorado convertible. I'm going with a slightly smaller mandrel in here. It's 16 at the moment, I think the next size down is 10. I'll meet you with the 10mm mandrel in here in a moment. Okay, I've swapped out the dies or mandrels for the 10mm and we'll start squashing it down. I'll probably end up with some bit of flashing on the side, but we'll see how we go. Okay, that's into bypass. So it's not getting any flatter. Let's see if it passed the tug test. Ah, surprisingly it does. Now, the keen amongst you will notice, I haven't upset enough people today. So I've actually drilled a hole in the top there. What I'm going to do, in addition to the crimping, is to solder it as well. And that way I get equal hate by everybody in the comment section. Okay, let's get on with that. So we're just going to heat it up now until we can flow the solder into that hole. That's it. And while it's cooling down, it's important not to try and move it around to touch it, because that can cause a dry joint. And then the most important step, well, that's covering the whole shebang up with a bit of double-sided, double-wall glue-lined heat shrink so no one can tell the bloody difference. Okay. Now the great thing about the dual-wall glue-lined heat shrink is not only does it tend to waterproof stuff with the glue in there, but it'll actually go down to 1/4 of its original size. So if you've got 20mm stuff and you've only got 5mm size wire, it will shrink down to that size, which is absolutely fantastic. And there you go, just like confession, all our sins have been forgiven. Right, on with some more wiring. And here's a classic case of heat shrink covering up sins. So this is a standard heat shrink which was covering this joint. This is a positive lead that runs down to the brush of the DC motor, and this one is the bit that runs out to your battery. They seem to have wrapped a bit of brass around there, is it? Perhaps, and filled it up full of solder. I have absolutely no idea why Kings have issues with the reliability of the electricals. None whatsoever. Anyway, I'll be fixing that right up soon. Now guys, if you're liking the content so far, don't forget to give it a thumbs up and ring that bell icon so you don't miss out on future content like this. And don't forget, for the price of a cup of coffee, you can get early access to videos like this, becoming a patron on Patreon. There's a link down in the doobly-doo. Anyway, on with the video. So here are the input cables made out of a spare bit of 35mm welding cable left over from a previous project. And I just realised I forgot to put a fuse on, but that's alright, I know how to fix that. And there you go, 150 amp MIDI fuse to protect our input cables and our supply for our Thumper Max. Alright, let's connect up the business end. Now the problem with using two coils of the same colour is I don't know which of these two is a positive and which one's a negative. But luckily we can work that out pretty simply. Now I'll put the coloured heat shrink on there to differentiate those two, so that'll work. But I'll have to use my multimeter to work out which one's which here. So if I put that onto continuity, there we go, and if I touch the two ends of the meter together, I should get a beep. Beautiful. So I'll put that onto the negative there, and I'll just touch one of them. It's obviously the other one, and this will be our negative. There we go. So we've got our negative there. So what I'll do is I'll just mark it with a minus. So I know that one's definitely the negative, and now we can go and put the negative side lug on that one. Okay, so just like usual, measure it up, grab your felt tip marker and work out where you need to strip back to. With that done, we grab our handy stripper, place it on the cable, once around, and then strip it off. Problem with this double insulated stuff is we don't seem to get the bottom very well. So what you're trying to do is avoid cutting into the insulation far enough that you're actually contacting the conductors below, because that will leave a bit of a mark in them and can lead to a fatigue point. So try and cut through, but not quite through far enough that it's actually connecting with those conductors. And break it the rest of the way. There we go. Okay, so we do a bit of a test fit now. That's good there. We're right the way up to the top. Let's get our hydraulic crimper. Place it in at about the halfway mark. Once it's secured in there a bit, just push that cable home all the way and keep going until we reach bypass. I think it's 2 grunts in total. There we go. We've reached bypass, and that's it. We've got a nice crimp connection there. Now just to finish it off and upset every single sparky available. I'm going to stick some solder in there. Okay, because it adds to the conductivity. Okay, so it's up to the top, ready to go. All we need now is a little bit of heat shrink over the top. Grab our heat gun and shrink it down. And that's it. We'll just let it cool down now before we install it onto the solenoid. And now it's cooled down a bit, we're going to install it onto the solenoid. With a couple of washers. And of course the nut. Then we just tension them down with a shifter. Because I'm dodgy and not using a proper spanner. Even though it's only about 2 feet from where I am. There we go. Now we need to do a butt join in between the original positive and our new positive here. Let's get into that in a moment. So I've cut off this abomination and I've stripped back the wire a little bit. We're going to use this butt joiner. So this is a reducer, 10mm to 35mm. So this being 10.5mm should slip in there with the factory tolerances, I hope. Hopefully we can get all the strands in. Oh, come on. There we go, a bit of a push fit, but if you're keen you can see the end of the wire down there. Now you'll notice I've drilled a couple of holes in there because I like upsetting people and I'm going to solder it right after I crimp it. Okay, so we'll put the crimper on it and see how we go. 10mm dies in there, I'll give it another crack. Down from 16. Okay, we're back into bypass. That looks a bit better. Give it the old tug test. Beautiful. Okay, now for the other side. So I've already stripped that one off. And here's the tip for young players. Put your heat shrink on first. Now with these unflared ones, they can be a bit of a bear to get in. But I'll get most of these strands in, I reckon. Okay, it's into bypass. Let's see what sort of job we've done. If we can get it off, that is. There we go. Nicely crimped. All I need to do now is to trim this up a bit and put the heat shrink over the top. Before I heat shrink it though, of course, I've got to drop some solder in there. And here we go, we're finished. So not only did I forget to press record when I was soldering this up, I actually cut the heat shrink a little bit short, hence the tape here. Now we're going to have to work out some way to support this cabling so we're not putting undue pressure on these joins. But now onto the control wiring. Now if you cast your mind back, in order to get the connection in between this side and this side, we need to supply the coil with both positive and negative 12 volt. So to get the negative, I've just bridged off our negative side here, and we're doing all our control on the positive side. So we've got a switch, the standard switch, and then we've got a pressure switch in series. That's 150 psi off and 120 psi on. So it needs to be below 150 psi in order for it to conduct electricity. And then we move on to the positive side of the coil. In fact, I think a diagram would be a better way of explaining this, so I'll do that now. And here's the basics of our wiring diagram. So we've got our power supply here, and then we've got a pressure switch here. So when that's below 150 psi, it's conducting electricity, or it's closed. There's our manual switch there, which is currently open. This here is our solenoid, and we've got our Thumper Max over here, and of course we have 150 amp fuse, so we don't let out that magic smoke. So let's see what happens. So when you close this manual switch, and assuming we're still below 150 psi, that then energizes this circuit here and turns on this electromagnetic coil. Of course then shuts the circuit here, and then we've completed the circuit through to the Thumper Max, and of course because that fuse is still intact, well, we turn on the Thumper Max, and that's how simply it works. Now, as you can see, during our works, a decent amount of crud has worked its way into our workings of our heads and our pistons and our cylinders. So what we're going to do is we're going to clean it all up, reassemble it all, re-lubricate it, and then we can start the testing. Finally! Now, I've reassembled the Thumper Max, but you'll have to excuse the cable management until we finalise the plumbing. Now, I've set up the oscilloscope with the current clamp here, and we're ready to capture the waveform, and we'll see if there's any difference. So off we go, and we'll go and have a look at the waveform now in comparison before and after. And here's how the solenoid turns on. Now, just like before, we've got the current in the left hand side here, and we've got the time in milliseconds along the bottom. Remembering 1 millisecond is 0.001 of a second, and this is a trace from the PCB using the oscilloscope. Let's compare it with a trace from the solenoid. Not nearly as clean, and we have a steeper gradient here. This is usually where it's arcing a little bit, turning on, turning off, which isn't unusual on a manual switch. But our gradient is a bit steep here, so that's not as nice on the electronic componentry in comparison with this curve here. But we seem to turn on at about 2.25 milliseconds there, and we maintain the same amount of current up the top there. So not quite as clean, but not too bad overall. Let's have a look at voltage drop. So I've got one of my leads from the mushy meter onto the negative of the battery, and the second is on the far side of the contactor, just like before, but instead of being on the far side of the PCB, this time we're on the far side of the contactor. And we're looking at this reading here. Let's turn it on for a second, get it under load. It's about 0.1 of a volt. Let's compare that with previously, and I hope there's been a bit of an improvement. So let's see if we made any measurable improvements with the voltage drop along that massive orange cable. Okay, on the left hand side here, we've got the voltage drop in volts, of course. Now the maximum, again, 0.36 or 3%, that's the maximum recommended voltage drop. The standard, that was 2.3%, so that was actually better than I was expecting. But let's see if all the effort we've done actually made a difference. 0.1 of a volt or 0.8%. Absolutely fantastic. So that's a 64.3% improvement. I'm pretty happy about that. So all that effort was actually worth it. Now, as I say, the proof is in the pudding is in the eating. So we're back up to 18 psi. I'll zero this current clamp here. Same car as before, same voltage source as before, same everything as before. Look, I'm not expecting miracles, but I'm going to get the data logging enabled just in case there are. And off we go, back up to 38 psi. And there we go, we're back up to 38 psi. I want to dance around a little bit for me there. Okay, let's compare before and after. Now on the left hand side here we've got the pressure in psi and current in amps. Along the bottom here we've got the time in seconds. Now if you cast your mind back, going from that 18 to 38 psi in that 315/75/16 tyre took 113 seconds, and it was just over 90 amps, about 92 amps consistently from go to woe. Righto, let's have a look at the result after electrical only modifications. 48 seconds and it was a little bit under, about 90 amps or so. All I can assume at this point is, now I did this testing after picking it up from King's directly out the box, threw it on the test bench and tested it, so didn't mess with it at all. I'm assuming there was an issue with the King's Thumper Max when I picked it up from King's. That's the only conclusion I can come to, because we can't go from 113 seconds right down to 48 seconds with just electrical modifications, unless I'm trying to throw 36 volts up his bum or something like that. There must have been an issue with the King's Thumper Max when I picked it up. That's the only conclusion I can draw. Anyway, so we've got a new baseline now, 48 seconds. 18 to 38 psi in that 35-inch or 315/75/16 tyre. That's it. So what do we think in the end? Well, we managed to slash the voltage drop performance by in excess of 2/3, which is absolutely fantastic. And we may well have picked up a bit of performance in the process. But the main thing is we now have the electrical infrastructure for the next round of modifications. Now guys, if you like this video, give it a thumbs up. And if you didn't, by all means, give it a thumbs down. Not once, not thrice, but twice. Thanks guys. We'll see you in the next one.